So today we are going to see about three-phase grid-connected solar PV system. So just you have to open new model, Simulink model. So and then go to library browser. Okay. So in library browser, just go to Simscape and then electrical, and then go to specialized power system. In specialized power system, click renewables. Okay. So you will see solar, right? So just click solar and then drag that mean place this PV array in the Simulink model. That mean workspace. That means Simulink workspace. Okay. So next you have to connect constant for irradiation temperature. So for that, once again go to Simulink browser and then click common list blocks. Here you can see that constant. Just you have to connect the constant block to irradiation and temperature. Change the value of irradiation equal to 1000, temperature equal to 25. Okay. Next to fix the series parallel combination of solar array. Here I am going to use 10 series and 47 parallel string, and then single panel has a rating of 213.15 watts. That means Soltech panel. The open circuit voltage is 36.3 and voltage at maximum power point is 29. Short circuit current is 7.84. Then current at maximum power point is 1.35. So here you can check the PV IV characteristics of that corresponding panel. So here you can see that at 1000 watts per meter square, the maximum power is around 100 kilowatt. Okay. Here you can see that 100,200, 100.2 kilowatt. Okay. So this is the rating of PV panel considered for this simulation. So next we have to apply MPPT algorithm concept, as well as we need to connect boost converter after the solar panel. So for that we need a capacitor, inductor and IGBT. So for that, just we go to power electronics, click power electronics, and then click this IGBT and place in the workspace, and then select the diode and place in the workspace. And then once again we need a capacitor and the inductor. Just go to click elements and go to, and then place that RLs here. First you need to connect some DC capacitor or capacitor across that solar panel. So here I am going to use RC. So just you have to use R value is minimum 1 e power minus 3, and then take capacitance value is 1000 microfarad. So after that, in boost converter we need to connect inductor in series with source. So here I am going to choose inductor, and then I am going to select inductor value is 1.5 millihenry. And then after that I am going to connect IGBT, and then diode. Here I'm not going to measure that IGBT details, and also I'm not measure the details of diode current. And finally we need capacitance at output side. So just I'm going to connect that capacitance. So here I'm going to use the capacitance value is 3227 e power minus 6. So next we need to measure the solar panel voltage and current. So for that go to commonly used blocks and select this one, bus selector, and connect that measurements, and click this bus selector. So we will get this signals in the bus. So we need only PV voltage and current. So select that PV voltage and current and remove that first two signal. After that just you have to use go to block, connect first signal and then connect second signal, that means voltage and current of the PV, and then change the name of that go to block. Here I'm going to change IPV. Next we need to generate a pulse for that IGBT. Here we are going to apply MPPT algorithm. Here I'm going to use P&O with PA control based MPPT. So for that I'm going to use user defined function here, and then I'm going to use this function, MATLAB function. So here I'm going to pasting that MPPT algorithm. Here you can see that we are going to measure the voltage and current of the PV panel, and I'm going to mention the reference maximum voltage is 363 and reference minimum voltage is 0, and the initial reference voltage is 300, and change in voltage and delta V reference is 5 volt. So this V and I will be the voltage and current of current instant. So we need to initialize another three parameter, nothing but voltage, power, and reference voltage in previous instant. That means we are going to consider volt, right? That means I'm going to make another three parameter: persistence V volt, P volt, V reference volt, and then I'm going to make all data type is double function. So not double, data type is double, and then here this loop, right? That means this if condition. Here we are going to check whether V volt is empty or not. If V volt is empty, then we have to provide value for initial value for V volt, P volt, and V reference volt. So here V volt equal to 0, P volt equal to 0, the V reference volt is equal to, I'm going to consider the initial V reference. Okay. After that, here we are going to calculate power by using current instant value. So P equal to V star I, and then next you have to calculate change in voltage, that means current instant voltage minus previous instant voltage. Next you have to calculate change in power, that means difference between current instant power and change in power, sorry, previous instant power. So next you have to check whether that change in power is not equal to 0, if change in power is not equal to 0, then we need to check whether change in power is less than 0 or not. If it is less than 0, this if else loop if else going to be executed. If change in power is greater than 0, this loop going to be executed. Okay, if change in power is less than 0, then we need to check change in voltage is less than 0 or not. If change in voltage is less than 0, then we need to add V reference equal to V reference volt plus delta V reference, or else we need to subtract that delta V reference, okay, with the V reference volt. So next, if this condition is false, then we need to once again check the change in voltage whether less than 0 or not. If it is less than 0, we need to subtract that delta V reference with the V reference volt. Otherwise, we need to add that delta V reference with the V reference volt. If TP equal to 0, so we need to maintain V reference equal to V reference volt. So no need to change reference voltage. So next we need to check the V reference value, whether that V reference is in between V reference max or V reference minimum. Okay, so if suppose the V reference is in between V reference max and V reference minimum, then we take V reference equal to, that means that means that V reference is greater than V reference max, or the V reference is less than V reference minimum, then so we need to make that V reference equal to V reference volt. Okay, that means we need to maintain the previous reference voltage. So after that we need to store the result of current instant to previous instant. That means V reference volt equal to V reference current reference voltage, V volt equal to V, that means which is equal to current voltage, P volt equal to B, so that means volt power equal to current instant power. So this loop will be keep on executing to extract the maximum power from the system. So here you can see that now I am going to save this model, because okay, after saving you will get two input, voltage and current input for that MPPT. Okay, so this is going to be taken once I go to singular routing, and then take that from block. Okay, and then go to discrete, and then take unit delay, place that one place here. In order to simulate this model, we need to add another block, nothing but power GA, right? Here you have to consider model simulation type is discrete, and then make a simulation time equal to 1 e power minus 6. Next go to modeling, and then go to model settings. Select solver is a fixed type solver. The type variable step, just to go to is fixed step solver, and then change the fixed step size is 1 e power minus 6. Okay, so here you can place sample time is 1 e power minus 6. Here sample time is 1 e power minus 6. So after that you have to use summer block, otherwise called subtractor block. So for that go to math operation, connect directly the output of this one, change the sign minus plus. Okay, So next we need to connect this from here. So after that we need to connect controller, PA controller. So for that go to continuous and then select this PID controller. Here we are going to use PI controller. So click that PID and then select PI and then change the value of the PI. P value is 0.005 and then integral value 0.001. So the PI controller will provide duty cycle. So that should be compared with some sawtooth waveform. So for that go to source and select repeating sequence. Here you can take that value for time is 0.002 and then output value in between 0 to 1. Okay, and both should be compared. So by using relational operator. So for that go to logic input operation and select the relational operator and then you connect this output of PI and output of sawtooth waveform and then change that value is greater than or equal to. So this is a pulse, period impulse from this block. Okay, so it going to be trigger the IGBT. So next you got to use signal routing block. Go to and connect here. Here you can type pulse and then make global. Okay, and then here you can change that name as pulse. So here we need to change HO volt VPV and then here IPV. That means so next you have to connect that connector in the output side. So for that go to that mean elements here, connection port. So rotate this one, connect here, also connect here, and then here you can change the name as plus. Here you can change the name as minus. After that just you have to select this area and create subsystem. And then here you can change PV plus and then here you can change PV minus. So here change the placement is right side. Okay, so this is DC DC converter, DC to DC boost converter with MPPT. Okay, and then this is known as measurement. PV measurement. So this part is completed. That means solar panel rating fixing and then the boost converter design is, that means boost converter implementation is completed. Okay, so next we need to create that inverter, 3-phase inverter. So for that, one sign goes to Powertronics and then take IGBT. So here we are going to model that 3-phase. Okay, so for that we need to use 6 IGBT. To connect this collectors, here I am going to connect emitter. So here you need to connect this DC. Here you need to connect negative, positive, negative. Here you need to provide pulse, okay, for triggering that IGBT. Also we need to connect connector elements, node element. We use this connection port, control R. So this is phase A, phase B and C. Okay, here change the name. A should be in right side. Change the name B and it also should be in the right side. This is also in right side. Change the name. See, okay. So next I'm going to make some subsystem. Here you can type plus plus, here type minus minus, so here take C and then this is PWM1, so this is PWM2 So this is PWM3 and this is PWM4, this is PWM5 and this is PWM6. Okay. Next we need to connect filter element. So go to elements once again and select series RLC branch. Okay, here connect RL. So here resistance will 1 e power minus 3, then inductance is 1000 millihenry, and then connect same kind of inductor. So next just copy and paste. So here make 500 milli. Just move little bit this side. So next we need to connect capacitive filter. So just to rotate this one and select RC. So here I'm going to use 100 okay, and then connect 3. Next process we need to connect a grid source. Okay, and go to electrical source and take this 3-phase source. Okay, and rotate this one. Connect here, voltage is 400, frequency is 50, then source resistance 1 e power minus 5, source inductance 1 e power minus 5, then voltage 400. Okay, so next process we need to measure voltage and current. Okay, so just remove this one. Next we need to measure voltage and current after this inverter, voltage and current here. Okay, so first we go to measurement block and go to 3-phase voltage and current measurement. So here you connect this one. Here I'm going to use label. Here I'm going to measure current only, IABC. Okay, I'm going to connect here, and also once again I'm going to use same measurement block here. Next, to connect these points. So next process, we need to measure voltage here. So for that, go to voltage measurement. Connect this voltage and then use signal routing and connect here. So make this is VDC. Okay. Next we need to convert ABC quantity into alpha beta as like here, right? That means ABC to alpha beta and then alpha beta to DQ. Okay. So for that, go to library, go to control measurements, transformation. Here you will get ABC alpha beta and alpha beta DQ naught, right? Click this one and then click this one. Here and then use signal routing. From block, okay, and then connect here and then click this one, update this one. So take VABC, next to do like that. That means here we need omega t, so not to generate the omega t, so we need to use this kind of loop, right? That means VABC alpha beta quantity, so that should be converted to DQ and then the Q axis quantity is compared with the 0, process API controller and then integrator, so it will generate that omega t. Okay, so I'm going to make this output of ABC to alpha beta not equal to alpha beta. So here I'm going to use this one, then I'm going to make this is alpha and beta. Okay, alpha beta, and then I'm going to use that same alpha beta here, alpha beta, and then alpha to beta, alpha beta to DQ, and then I'm going to use Dmax. Okay. Dmax, so there are 3 output from that Dmax. After that I'm going to use summing block, sender output is connected here and then going to be compared with the reference, that means 0. Connected with the 0. After that you have to use PI controller, So here we are going to use PA. I will is 10 and then integratively 50,000. Okay. After that use integrator. Okay, and then take feedback here. So this is nothing but omega t. So here I'm going to make this is nothing but omega t. So I'm going to change omega t. And then here we can use that omega t here. Okay, this is omega t. And same ABC to alpha beta for a current. So here change VABC to IABC. Then once again use alpha beta 80. So next use Dmax. So there are three output. So these three and then so first one is VD and second VQ. So same way we connect Dmax here. The first one is ID and I, second one is IQ. So here you can use this is VD and this is VQ and this is ID, this is IQ. Okay, so small problem, so you don't use this one, use this one, this transformation ABC to DQ. This is a transformation conversion. Okay, it's like in this. So next you have to implement this loop, right? So 700 is compared with the VDC, that means this one. Then process we have PA and then is compared with ID. So we need to implement this one. So first you have to take constant, okay, and then summing block. So this will be changed to plus minus. Here value you would set 700. next in the input will be VDC. Okay, VDC. So after that you have to use PA controller. The PA controller parameter is zero point 0.25 into 300. Here you got to mention 0.25 into 300. Okay. So after that is going to be compared with the ID. So this is ID. After that it going to be processed via next PA controller. Okay. So that value is 10 into 20. This value is 10 into 20. 10 into 20. Okay. So after that it going to be added with the IQ. Okay, IQ with some constant, right? This one IQ is added with here, so the constantly this value you have to use this one. So that means take IQ and then take gain block. The gain block value is this one. So after that it going to be added with the VD. Okay, so take date and VD. VD and then you have to use another gain block here. Here you can use gain block. The gain block value is 2, and then next you got to use this one, this one. So you have to multiply the output and divide by VDC. So this is a one control block. Okay, so 700 VDC PA. So next you have to take this control block. Okay, that means this portion, right? Only this portion take as it is, copy and paste. Yeah, so here the input will be 0. Here input will be 0. Here we need to use IQ. And then PA controller. Here we get to use ID. And then here this VQ, and then anything same. Okay, so next you have to use mux So max input receive three inputs. One is this one, this control signal. Next one is this one. The third one is 0, so no, don't worry about that. So next, that detail going to be converted into ABC. That means DQ not to ABC. So once I go to transformation, use this one, and then take take this one. So this is a control signal. So next process, we need to generate the PWM impulse. So for that we need to use triangular, right? So for that we go to repeating sequence, go to repeating sequence, that means sources, go to repeating sequence, and then type 0.0005 and then 0.0001. That means 0.405. Okay, and then here -1 1 -1. So repeating sequence. So that should be compared with this ABC quantity. Here I'm going to use Dmax. So there are three output from that Dmax. So I'm going to change 3. And next I'm going to compare these things. Okay, so for that I'm going to use relation operator here, which be greater than or equal to symbol. So here I'm going to compare this one, and then here I'm going to compare this one, and here I'm going to compare this. So same control signal, that means carrier. Okay, so here we will get 3. So next I'm going to use NOT gate to invert that pulse. So same signal given, then here, and then here. Okay, and then I'm going to use signal routing. Go to block, that means here the first one is PWM 1. Okay, so here I'm going to change PWM 1. Here this is PWM 2. This one is PWM 3. And this one is PWM 4. And this one is PWM 5. This one is PWM 6. to make subsystem. So this is nothing but a PWM generation block. Next one is need to give the pulse for here. So here is from so this is PWM 1, this is PWM 2, and this is PWM 3. Three, then PWM 4, PWM 5, PWM 6. So next we need to measure the voltage. So for that go to things, take scope. Here we need to measure VABC, IABC and VDC. Okay. Go to configuration block. Totally 3 layout, 3 inputs. So one is VABC, next one IABC, then VDC. Next we need to measure power. Further go to measurements, use 3-phase instantaneous power. Here so input VABC, IABC, and then use display. Checking of the result, just simulate this model. So this is DC voltage from the boost converter. So here that means here the 700 volt is fixed here, right? It maintain around 700 volt. So this is VABC and IABC. Then this is power of P panel. So around 100 kilowatts. Suppose I'm going to change the irradiation. Okay, well, I'm going to change irradiation is equal to 500. Here you can see the variation. That means change to 50% of the PV panel power because of irradiation change to 500, right? Now the power is 50 kilowatts. Okay, here also you can see that real power is near 50 kilowatt. So because of change in that irradiation, you will see that current variation. Okay, so we can change the irradiation, check the result. Okay, thank you.